All right. Hi, everyone. I'm Jeff. This is Arik.
Hi.
We work at Spiral on a project called LDK. So I want to try to make this a very interactive sort of session here. So I guess maybe hands up, who knows what LDK is? Everyone. Okay.
Wow.
Someone tell me, what's LDK?
It says right there.
There we go. That was my joke. You heard it. All right. So it's the Lightning Development Kit, or the Lightning Dev Kit for short. Yeah, so anyhow, what is LDK? Yeah, so it is an implementation of the Lightning Network Protocol, but as an SDK. So maybe you could think of like, Core Lightning or Eclair or an LND, right? Those are implementations of the Lightning Network Protocol, but as like a binary that you just run, and you can configure it in certain ways, but it doesn't really allow this like fine-grained sort of customization, which we're kind of hoping for of LDK. So. LDK handles all the complexity of the Lightning state machine, which is, if you look at the bolts, it's kind of crazy what you have to do to implement Lightning. So we do it for you, basically. And if you want to go to lightningdevkit.org, you will find a lot of resources there. And the material will be refined along the way, but we're going to try to kind of give you a more than superficial knowledge of what LDK is. So why LDK? It's lightweight and performant. It's written in Rust. Who likes Rust? Few people like Rust.
What was that?
But wait, it's multilingual too. So we have these things called language bindings, and it's a way for you to write your app in whatever language you want. Aspirationally, we're starting with a few languages that are more mobile focused, like Java, Kotlin, Swift. And from there, we let you kind of customize things or take things out of the box if you wish. So we're going to kind of dive into the architecture and let Arik take over for now. And but again, pipe up if you have questions, and we'll make this really interactive.
Yeah, definitely do feel free to interrupt at any point, because at some point we do want to go a bit more into the weeds of how LDK is structured. But here I do want to start with a general overview. So first of all, the thing that is really curious about LDK is it's not a daemon. It is an SDK, which means that it is code that gets compiled into your application. And what that means is that it has to be extremely environment agnostic. So in particular, it means that it knows nothing about your networking stack. It knows nothing about your data storage or persistence. It knows absolutely nothing about the blockchain either, which means that you kind of have to provide all of those components for it. And there is kind of a nice mapping of which components you have to provide for what. So if you think about how you work with the Lightning Network, the very first thing that you do is you need to connect to a peer. Not even so much as open a channel, just literally open a TCP connection to the peer. And that is what peer management is for. And in order to accomplish that, let's see if I have pointer functionality in here. Nope, I do not. Oh well.
So one thing to note, though, is we're trying to be as less opinionated as possible. If you want to do things like obtain the blockchain data from a certain source that's preferable for your setup, you can do that. So less opinionated is our goal.
Right. So as I was saying, to connect to a peer, you need to plug in your own networking stack, as you see there represented by net.io. And once you're connected to a peer and you want to open a channel, you have to have some sort of channel management in order to be able to manage a channel, to open a channel, to see that your channel has not been forced closed because your counterparty is being mean to you. I was going to use a different word. You also need to have some block sourcing interaction. So you need to be able to see what the latest data is on the Bitcoin blockchain, and you also need to be able to broadcast, say, the channel open transactions or the breach remedy transactions or whatnot, or even HTLC claims if one of those were to be persisted to the chain. So that is why you have the chain interactions modules there. The thing that's really cool about LDK, in my opinion, is it makes sure that it never progresses to a state of the channel state machine until it is safe to do so. And that is done by making sure that whenever there is something critical, like a revocation secret is about to be revealed, it needs to make sure that you first persist the current channel state. And that is why we have the synchronous interaction with the data storage module, where you can implement an interface and before the channel state machine advances to the next stage, you first make sure that your local persistence or your cloud-based persistence or whichever it may be is done, and only then do you respond saying, all right, feel free to move on, LDK state machine. And lastly, of course, LDK obviously doesn't assume anything about your source of entropy or about your wallet. So there is a bunch of wallet tooling and key management and signing and entropy, if you so wish, that you can also provide to the Lightning Dev Kit.
Yeah, could you talk a little bit about the untangling aspect of LDK?
Yeah, so one thing that you will notice as you work with LDK is that every once in a while it will prompt you to do things, potentially asynchronously, such as, for example, you want to open a channel, then it needs to figure things out and then tell you, all right, if you want to open a channel, just send some funds to this output script. And there are other similar things that we're going to address in more detail later on, but essentially a recurring theme that you will notice as you build on top of LDK is that you're going to need to be handling events, most of which are emitted by the channel manager, which we are going to talk a bit more about later. One minor note at the end of this slide is that we also have language bindings. Right now we have language bindings for Kotlin and Swift, and I think we also have something for JavaScript in the shape of WASM, although that's more of an alpha stage. But there are implementations that are currently building with LDK on iOS and on Android, and it's kind of insane to see the sort of flexibility that they are afforded simply because they don't have to have a full node or a full Lightning daemon running on a mobile device, which would be, frankly, insanity.
So any questions at this point?
Do you have Go bindings at all?
Go bindings, not at the moment, but we've heard some interest. So
yeah,
anyone?
people trying to get off LND.
Okay.
I mean, is language dependent, but like for Java, would this just be like a library that I can download in Java and then just run all my tool chain as I would, or
Yeah.
is there? Oh, okay.
Yeah, it's a library. It is compiled into whichever format Java libraries need compilation into.
It's on Maven, I think, too.
Okay.
Yeah, so for some things we'll do like, we'll generate C bindings, and from those we can generate bindings in other languages.
Oh, okay.
But for like the network I/O, we'll have a custom implementation for it.
Okay.
Yeah, so I just want to dig a little more. I have addressed this in the previous slide a little bit, but I want to dig into the peer management aspect specifically, because that is literally the first thing that you have to do as you start building your own Lightning node, which is you need to connect to a peer. And the object that is exposed to LDK that you're first going to be interacting with is the peer manager. The peer manager has some underlying dependencies, such as the channel manager. So the peer manager can tell peers when it wants to open a channel and then initiate all the corresponding gossip messages. The peer manager also talks to the peer-to-peer gossip sync, which understands when other peers that you're connected to send you updated gossip messages, or if you want to forward others, or if you want to announce channels. So this is the sort of handling that happens there under the hood. But the thing is, LDK knows absolutely nothing about your networking stack. So in order for you to actually be able to connect to other peers, you need to implement the networking stack, where you essentially simply get raw TCP socket data, and then you stupidly pipe it right into LDK, and LDK will know exactly what to do with it. It's really convenient. And in fact, we even have a default implementation that handles that for you, called the background processor. The background processor also takes care of some other tasks that you are going to need to do as you deal with a peer manager, because you're going to need to do some periodic calls. You're going to have to do things such as timer tick occurred. That is a method that makes sure that ping pong calls are handled correctly. And there's another method called process events, but we'll dive into that as a part of the weeds component of this presentation.
Is there any Tor support at all yet for any like Tor network implementation, or anyone working on that?
Someone asked about that. I don't believe there's anything right now, but it's easily kind of plugged into.
Yeah. You can
So
just
we are
swap
not
it.
opinionated.
Right.
So if you can route the TCP sockets over Tor, then you can just.
So could you
hijack.
completely do that within the little NetIO box? Would
Yes.
it just all fit in there?
Yeah. So NetIO has this little beautiful stitching that our designer just created an hour ago. By the way, huge shout out to Stephen. And Yeah. And that is to say that this is a completely drop-in component where you either can use some of our pre-existing defaults or where you may want to write your own implementation if you want to address some new environment that we just haven't addressed it before.
Mm-hmm. Yeah, so to kind of dig into some of this just slightly a bit here, like you're reading from the network. The peer manager is sort of delegating to each of these handlers, this channel manager and the P2P gossip sync, and those are producing essentially other internal events to LDK for the peer manager to say, okay, send these messages back to my peers. Essentially. All right, now we're going to jump into channel management. All right, so this is like kind of digging into that roughly that channel manager box we saw on the previous slide there. Oops. So that one right there. There's a few things that are, I guess, required of the channel manager. It has to have a way to sort of persist the disk, so we have that data storage down there. It has to have a way to broadcast transactions. So say you have your funding transaction that you supply to LDK, it needs to be able to send it to peers on the Bitcoin network, and you get that transaction mined. It also has to listen for new blocks, because as there are more confirmations, your channel will be will hit like a minimum essentially for you to be operable. And you also have to monitor for any sort of like unilateral closes that your peer may do, or maybe even like if they publish an old commitment transaction, you want to sort of rectify that with a justice transaction. So by sort of feeding blocks into LDK, it's going to handle that for you. Let's see what else we have on here. A fee estimation, of course. So when you are constructing a channel, you need to make sure you pay the right fees, and as well during like negotiation at shutdown, we'll sort of call out to a fee estimator that you provide. There are other various ways to do that. You can call out to like Bitcoin Core. If you have a Bitcoin node running, you might be using a third-party trusted service. And again, not very opinionated on this. There's just in the Rust terminology a trait, like interface in Java essentially, that you implement, and you kind of supply it as a parameter to your channel manager. Another important thing on here is essentially the difference between off-chain and on-chain. So who knows what I mean when I say off-chain and on-chain here? All right, great. So just to recap for maybe people that are not as familiar, or maybe listening later on video, we have two essentially components here. Channel Manager, which handles everything off-chain. So by off-chain, I mean like all the messages on the Lightning Network that are sent between peers for managing your channel. So these are opening and closing the channel, I guess routing payments through your channel, etc. Now the channel monitor is something that is basically a component is for sort of monitoring the blockchain for updates and acting accordingly. So again, on-chain, and sort of updating the state of your channels. So that's where kind of the data storage fits in. Like as we are progressing through blocks being connected and messages being sent between peers, we have to make sure, as Eric mentioned earlier, that we don't advance until you're ready to have all the state is backed up into the storage. So that's where we kind of handle that. So it's very important that the channel manager gets backed up at each sort of block essentially. There's some more wiggle room with the channel monitors, which we really won't get into at this talk. But you just know that's the sort of the breakdown. Channel manager is for off-chain, channel monitors are for on-chain. Any questions on that?
Yeah, two little questions. So you mentioned like you detect like an early state published or something, and you want to send a justice transaction. Wouldn't you want the mempool access to be able to do that instead of just from the block? Or is maybe that arrow?
I mean, I guess our arrows here, there's two. Oh yeah, I didn't go into detail here. So broadcasting transactions, that the lines sort of depicting, okay, we're broadcasting whether it's a justice transaction or an opening transaction.
We're not monitoring the mempool. We are just monitoring persistent blocks.
Yeah. And
that still gives you sufficient time.
Okay.
Yeah.
And then can you talk about the nature of the arrow that goes to the event?
Oh yeah. Let's get into let's like maybe kind of run through an example in a minute. One thing I just wanted to call out prior to that is your question about the blockchain. There is that you are responsible for basically feeding new block data into LDK, particularly in the channel manager and a component that sort of wraps those channel monitors called the chain monitor. Not going to really go into detail there, but that could be something that could be remote or it could be local to the process. And sorry, what was the question about the events, right?
Yeah.
So let's try to think of an example of when like an event would happen. So say
What are the publishing, like, are you subscribed, is it pops up, like?
Oh, okay, so-
like the actual.
yeah, the mechanism there. Okay, so you will have different components within LDK that can produce events, and those are the channel manager and this thing called a chain monitor, which is wrapping those channel monitors. You are essentially required to query that periodically. And from that, you'll pull events out, and you will have an event handler trait that you implement, and just basically say, pass that to a handle or a process. I think it's called like process events or something like that. Process pending events, I believe it's called.
Handle event.
Oh, yeah.
So
it's something
the
like
trait
that.
that you implement is handle event.
The trait you
thing on the
implement is
peer
handle-
manager is process events.
Yeah.
That's a little
Yes, yes. But then this background processor that Eric talked about kind of pulls all those strings for you. You know? So that's the sort of the idea there. We'll jump into some more details of what these events are and how they are sort of processed.
Yeah, we have very cool sequence diagrams coming up very shortly. Yes.
For the database and data storage, like, is that just like completely agnostic, like,
Yes.
like Postgres?
You just get
Yeah.
serialized bytes. So you mostly, there are different things that you are able to persist. You can persist the channel manager. You persist each individual channel monitor, and you can also persist the score and the network graph if you want to cache your lightning gossip. However, what you get is literally just a byte stream, which is fairly compactly serialized, if I do say so myself, and more importantly, Matt Corallo says so himself. Yeah, that carries a lot of weight.
Do you have to come up with like your own schema then for like an SQL database, or is that?
No, the byte stream is just a byte stream. We have a schema for the SERDI stuff, the serialization, deserialization.
But if you wanted to like break it down, you would have to come up with your own schema.
Yeah, you can persist it into a file. You can persist it
Yeah.
into a row in a database. Just as long as you know what you need to access when you then instantiate things at the next launch.
Yeah, it's like an exercise, maybe I could follow this. The channel monitor persistence interfaces, they have like a way to do like journaling essentially, so you have like updates and not just like the full channel monitor each time. And I think, Ryan, you're kind of alluding to some of that, but that's maybe outside the scope of the talk today. We could get into it later though. I'll be present at the hackathon if anyone's gonna be there. Yes?
Is the idea behind this architecture for like a microservice architecture implementation where you can have both remote and local assets?
Yeah, it allows for
Yes,
that essentially.
among other things. Or you could just be remotely and then wait until you have confirmation that stuff has been persisted in the cloud and or encrypted in the cloud, and then you move on to the next phase. It's like really whatever you want it to be. You have full control and hopefully full mastery of what and when things.
So in a project file, you just use the crates that you need for whatever your where your data is, where your input and output is going to, and then you can, I guess that's the interface then.
Yeah.
Okay, thanks.
Is there any like versioning to the bytes that come in? Like, what if there's like an update? And
Yeah, we try to be as backwards compatible as possible. Some of the structures that are serialized do have versioning, and we'll call it out in the release notes if we break something. We'll typically have a number of like a few different versions before we say, okay, we're no longer going to support an old version. So it should be pretty good for you just if you monitor release notes before you kind of upgrade to the next version. Just be mindful of that. There should be like a section on serialization compatibility in each release. The next release should be out today, soon, hopefully. So if you find something on the slides that are not in the code, at least the documentation, that's probably why. All right, let's continue on a bit. So I think I talked a lot about this. We talked about how to persist data and where. On cloud backup, you could do that. If you want multi-home setup, that's perfectly in line with what we said or support here. Whether it's encrypted, remote, etc. I'm gonna kind of plus. Oh, this is yours actually. Sorry.
It's fine. It's
That's all right,
really,
you know what
yeah,
I'm
we
talking
have
about.
already addressed the persistence aspect. One thing that I do want to dig slightly into, and yeah, we still have some time left, is that you actually have a choice of which paradigm you want to follow when you feed chain data into LDK. Because by default, if you want to do something really simple and super reorg resilient, what you're going to do is as a new block comes in, you're just going to call the block connected method on 2 exposed LDK objects, and it's going to handle everything for you. If a block gets disconnected or a block gets reorged, then you simply call block disconnected in the reverse chronological order, such that as blocks get connected, you call that method, you alert LDK of those blocks sequentially, and then if you have a reorg and like 5 blocks get removed, you first call block disconnected in the latest, then the second latest, and the third latest until you have reached the common block, and then you connect the new ones.
Yeah, and the great thing is we also have tooling that does this for you.
We do have tooling that does this for you, so you don't have to think about it too much, unless of course you are me and you have to write unit tests for that in a separate language for language bindings. But hopefully you're not me. The other paradigm though that you can do is if you want to do something like compact block filtering or neutrino or electrum or any of those really nifty protocols, other kind of nifty. You can also use a different trait that we support, which is a combination of the confirm and the filter traits, which you can read up more about on our documentation website. But basically those allow you to inform LDK solely of individual transaction outputs, of output scripts and TX IDs. So that way you can have a much more compact interface, and you don't need to have full knowledge of blocks, especially useful on mobile clients. So I think that flexibility is really alone a major selling point for LDK in my personal opinion.
Yeah, and honestly, like having some users first, like BlueWalt, for instance, started integrating with LDK early on, and they were using Electrum, and our interfaces really didn't conform to that. So we came up with this, this separation between listening to blocks versus listening for transactions that you have confirmed. All right, this one's me. So we're gonna jump into just some examples of event handling and how this works. So here's an example of basically opening a channel where the user of LDK, the developer here, is the one initiating it. So it's an outbound channel. So in LDK, a lot of the interactions you'll have as a developer will be through Channel Manager. It won't be solely through Channel Manager, but that's going to be at least for this interaction. There's a method called create channel. You supply some parameters for your channel, and then internally in LDK, it handles all the bolt messages. So I think it's bolt 2, if I got it right, for opening a channel. So it sends an open channel request to your peer. Your peer responds with an accept channel. Then LDK is like, hey, your peer is okay with this channel. I need a funding transaction. So it sends you that event, funding generation ready. It's in purple there. From that, maybe you're querying your full node to get a transaction from some of your outputs, and you call back with funding TX generated. I think it might be fully spelled out there, but and then from there, LDK takes over again. So essentially, during the event handling, so you're getting that event, you're periodically querying for new events. You find that, you can do whatever logic you want there for handling of events, and they'll be more important later on when we talk about accepting channels. But yes, question.
What about signing transactions? Like how does that work? Is that a separate component as well?
Yeah, so it was sort of bunched together back under Wallet, but there's a bunch of different interfaces around that. So there's actually no Wallet component within LDK.
Cool. And then so when you go to open a channel and things, you can sort of specify how that works.
Yeah. That's also an interface that you can implement called Keys Manager. And there is really interesting work by Miron and Ken Sedgwick called the Verifying Lightning Signer, which aims to completely abstract the Lightning channel state update signing machine into its own individual module that could hopefully be even completely disconnected from the network and work around on an HSM.
I think John Cantrell will talk about the signing part because he with this work with BDK.
Awesome.
He's in the next. He's the next talk in maybe a different room, but go to that one.
Yeah,
Jeff, forgive me one little thing that I want to add, but the thing that's really cool that I think is going to be relevant for all of you who are going to be at the hackathon is when you get the funding generation ready event, it tells you which output script you want to fund. So then however your wallet logic may be designed, you create a transaction that funds that output script, or maybe you simply have a Bitcoin D node running with a ton of Bitcoin in it, and you tell it, hey, send money to this address that corresponds to that output script. But whatever it is, as soon as you know what that is, and you have your transaction, and you feed that transaction back into the LDK using funding TX generated. And I realize now that perhaps we should have added that as a parameter, but live and learn.
Yeah. So LDK takes over from there. You had part of the sort of parameterization of Channel Manager is to give basically a object that is able to broadcast transactions on your behalf. So it will use that to broadcast your funding transaction, and of course then it will say, okay, funding has been created. Comes back, the peer comes up with funding signed, and at that point you're just waiting for enough confirmation. So now we show kind of feeding LDK more blocks, block connected, and eventually when you get enough confirmations, LDK is like, okay, we're good to go. Channel ready, which used to be called funding locked, and you get the same thing for your peer because they independently will monitor the blockchain for enough confirmations as well. I think that's all I wanted to talk about on this one. Yeah, let's continue on that unless there's any questions. Actually, one thing I didn't mention, there are some other events kind of associating with this whole channel process. For sake of time, I would say go to the documentation and read up a little bit about these. But there's some that are sort of like strictly notification, like channel has been closed, and there are other ones like funding generation ready, where you actually have to make a call back to LDK to sort of make progress on the particular activity. In this case, opening a channel. Here's the same thing, but for inbound channels. So your peer is the one that calls or sends you an open channel message. So at this point, LDK will give you an open channel request, and from there you can decide whether or not you want to accept this channel. So this is again another little hook where you are responsible for like determining, I guess, if you want to open this channel or not. And you do that by calling accept inbound channel. There is a separate method, I don't remember the exact name, but it's for zero confirmation, which is in the next release. That should be released hopefully today. And the same sort of procedure happens here. So that's channel opening from inbound and outbound. Any questions? All right, let's continue. All right, payments. So okay, once you have a channel open, what do you want to do? You want to pay people, right? And you want to receive payments. So we're going to go into what is involved in that. So from a high level, you have, when you make a payment, you want to basically find a route from yourself to your peer, or to the recipient of the payment rather, and you want to find a route that's maybe pays the least fees, maybe it's the most reliable one, and we use a scorer for that. It's a pluggable interface just like anything else. So we provide one called probabilistic scorer that's based on some of like Rene Picard's work. We have a router that is able to basically take a network graph that is constructed through this peer-to-peer gossip that LDK also handles, and from that come up with a route, and then for giving that route, which has enough capacity, enough liquidity rather, to send a payment, you hand it over to a payer, which Channel Manager is something that could pay. So Channel Manager implements this payer interface, and there are a lot of events involved and back and forth. So we'll go into that right now. Any questions? I know I kind of went through kind of quick there, but I just want to make sure we have enough time. All right, so this is what it looks like.
Yeah, so big full screen sequence diagram that I have been so looking forward to. And this is essentially the structure, a nice overview of what happens when you want to complete a Lightning payment. So first of all, we have your app, and you are the payer, and you are, in your app, you of course also have the LDK. And let's assume for the sake of symmetry that the recipient's app is also relying on LDK, and that we have a bunch of Lightning nodes in between, or Lightning channels rather. So what happens first? The recipient wants to create an invoice. So their app calls the LDK method create invoice, which immediately returns an invoice object, which then gets magically transported out of band using carrier pigeons to the paying app. QR codes are so last century. So we have that invoice here, and we call the pay invoice method on the payer LDK app. What happens there is the HTTP dance, and that is basically just an abstraction because we have multiple lightning messages that get sent between the peers over the gossip network, and it's back and forth, and it's also multiple messages in the same direction.
Yeah,
so
you notice
kind of,
not your immediate peer necessarily, just your immediate peer, there's multiple people on
Yeah.
this path.
It's a multi-hop band. I don't know if you have any selections. I've never taken any, but I'm sure that's next level. Your instructor will be present. It produces the pending HDLC supportable event on the receiver side, and as soon as you receive that event, you see how we have a lot of different events that require handling as part of dealing with LDK. But the thing is, usually the name of the event that you have to handle is a very clear indicator of what you have to do next. So you got pending HDLC forwardable, what do you have to do? You have to process the pending HDLC forwardable. You simply call it, and LDK takes care of that. And you have just claimed your HDLC, and in so doing, you have opened your HDLC commitment rather. In so doing, you have received a payment received event from LDK, and as soon as you get that, you can call the claim funds method. And once you call claim funds, two things happen simultaneously. So your LDK, first of all, with you being the recipient, sends you a payment claimed event, which you can monitor for to make sure that everything has succeeded end to end. And simultaneously, it initiates the propagation of the update fulfill HDLC messages across the Lightning Network to the payer. And then the payer gets a payment sent event from their LDK instance, and immediately after that, usually a payment path successful.
Yeah. Just to jump into a little more detail on some, I guess, non-standard cases here. So in this pay invoice method call we have, there's actually a couple things going on. There's an abstraction in LDK called invoice pair, which is, I mentioned kind of earlier in the passing that it has a router and a store, and it also has something that's called a payer, which is essentially the channel manager for sending the payment. So that pay invoice is first, computing a route based on some scoring, it's getting the route back, and then it's using that as an input to the channel manager for sending the payments. Now, if everything's okay, you'll get this payment sent, and then for each path, it's more for multi-path payment, you'll get a payment path successful event. Now, some of those paths may actually fail, and in that case, this invoice pair has some logic where essentially what it does is it is sort of a wrapper around your event handler. It's kind of like decorates it a bit, and it will intercept the payment path failed events. It will then be like, hey, I got to find a new path. It may like update some scoring based on if the path was failed or even successful payments earlier on. So it kind of learns knowledge along the way. Once that happens, it could then query. It could basically do a find route again, get a new route for this failed path, maybe even split up into multiple paths if it wants to, and then retry that portion of the payment. And so it has all that logic for you. Like, you don't have to use that abstraction. You can do it all on your own if you like, but it provides that mechanism, and it's like a demonstration of how LDK has some higher level abstractions that you could like use, and also it kind of intercepts some events for you and does the handling on your behalf. I think maybe in the future we'll probably want some more standard sort of event handlers that will do some of these calls for you, and then provide ways for you to kind of override behavior as needed. So that'll be helpful for people that just want to keep going and don't want to know about every single call you have to make. So, yeah.
Any questions about this sequence diagram?
Could you help illuminate a little bit of what is happening during the HDLC dance from the LDK perspective?
Okay.
So there are a bunch of methods or messages that are sent between first you and your immediate peer. So it's usually update at HDLC. You can send a bunch of those. It's a very sort of asynchronous protocol. If you go to Bolt 2, there's a nice little sequence diagram of what that looks like. I can't remember all the messages on hand, but essentially there's a back and forth between your peer, like you're signing commitments and such. And then you're ready to progress to the next, basically.
But a lot of that happens in ways that the app doesn't necessarily get blocked on an event that the app has to handle. Most of that is pretty automated.
Yeah, so going back to one of the earlier slides with network and peer management, basically the peer manager, yeah, if you want to go back, so the peer manager will sort of delegate to the channel manager and be like, hey, I got an update at HTLC, I need to respond to this. There's like revoking old states and everything. And it basically is producing these internal events, we call message send events. And so it's producing those events to send back through the peer manager to your peer. So usually for those, you don't have to do anything at all.
Yeah, and really it's two sequences that are happening, right? Because you have to send the payment sphinx, where it's the onion messages unwrapping who the next recipients are, and then you also have to send the HTLC since that's basically what we call the HTLC dance, because it's a lot to describe in one sequence diagram. However, here let's address all the different kinds of events that can happen.
So we talked about pending HTLC is forwardable. So Eric, I think you mentioned that, like, as you either are forwarding it on to, you might be a channel along the way on a payment, or you might be the recipient. And so based on that, LDK will either forward that along or tell you, hey, you received a payment, now it's the right time to claim it. So the flow of payment received and payment claimed, this payment claimed is actually a new event for this next release. So basically when you when you get a payment received event, you're now required to call claim funds. But there are some rare situations basically where you're not able to, maybe like there's some timeout that happened, and because of that we actually produce this payment claim if you're actually successful at doing it. So a payment is actually not received, like fully received, until it's been claimed and you get that event. And then payment sent and failed, like payment sent isn't really a payment success, but that means like all the paths have been successfully sent to your peer and you've received basically the pre-image back, and now you fully claim the payment. And then analogous to that is the payment failed. If there's any problems along the way, there'll likely be a reason why it failed, I think, in that, but I can't recall. And then again, for individual paths that have failed, we have some abstractions for retrying those paths if you don't want to handle them on your own.
Alright, so one thing I just wanted to address is that if you want to create multi-hop payments, you will probably need a network graph such that you know which way payments can be routed, which Jeff already alluded to earlier with the whole routing logic. But the thing is, you need to know what graph you can route payments on to begin with. And for that, we actually have two mechanisms. So we have the peer-to-peer gossip sync, which simply asks for the entire gossip from the first 5 peers that we connect to. And that way we are able to build a relatively high fidelity network graph. There is this new rapid gossip sync coming out with release 107, which hopefully gets out later today, but worst case next month. And
2 weeks.
2 weeks. Rapid gossip sync is this mechanism where you are able to download a super compact snapshot of the gossip data from a server that you either trust or even run yourself. I'm going to open source. Actually, I have already open sourced the code, and hopefully we'll be able to merge some of it over the coming weeks. And that is simply an alternative which could be quite handy for mobile devices where you still want to not rely on a service provider to route the payment for you, but you also don't want to have to wait a couple of minutes until your network graph is fully up to date. So with Gossip Sync, you can download something that gzipped is about 2 megabytes, and then within 3 to 5 seconds, everything is fully processed, and then you can immediately start routing your payments.
And you get incremental updates too to that, right?
Oh yeah, it supports incremental upgrades. It's quite, again, nifty, but the docs are already available.
LN sync.
It's similar.
But it's inspired by that, but optimized like hell. Like that thing is incredibly compact. I couldn't believe it myself, because when I look at a network graph that is serialized traditionally compared to one that is serialized using rapid gossip sync, it's like tens of megabytes compared to 2 megabytes. And,
the important thing here though is that it's your choice of what you want to do. If you want to use the Bolt 7 P2P gossip sync, you can do that. But if you're on a mobile device, maybe the rapid gossip sync is better for you, or maybe you have maybe just like a trusted third party that you want to delegate routing to. You don't even want to have anything to do with the network graph on your device.
Yeah, that's the thing. It is not strictly necessary to run gossip locally if you want to pay an invoice, because you can have a service provider simply return you the route, and you still have to technically implement the route interface, but then what you do there is you implement it in such a way that simply takes that given route and feeds that into the invoice pair. So.
And you can do trampoline with this too then. Does it support trampoline? Or
We do not support trampoline yet. However, we will probably support it.
Yeah, I think the spec
near
still
future.
is being ironed out on that. So like async has some sort of trampoline support, but I think there's like a new version of trampoline that's not quite the same as that. So, but there seems to be a lot of interest with getting trampoline moved forward. So we're running a little short on time. We've got 5 minutes. Maybe we're even over. Depending, we got 5. Okay. Just for me or you?
Well, I can address it a little bit. So one of the things that I wanted to add, like you have noticed the theme throughout, so here I just wanted to address that theme, is that there are some ubiquitous requirements that are necessary for handling for working with LDK. First and foremost, as is reflected by the slide, obviously, event handling, like you keep those events just keep popping up and you always have to handle them. Some other things that you have to implement the logger trait. It is necessary, but it's actually a good thing that it's necessary because you'll be doing yourself a disservice if you chose not to implement the logger, because whenever there is a weird error happening in Lightning, and in Lightning there are so many potential sources for where an error can originate, having the logger is a huge boost for your debugging ability. You also want to implement the keys manager for the entity handling and for signing transactions. I have addressed the React Gossip sync, and the thing is, there are also some default implementations or reference implementations to provide if you want to handle things in a more or less standardized environment. So we have the background processor that takes care of handling the peer manager. And so we also have Lightning Net Tokyo, which handles the network stack in Rust. The chain monitor as a default implementation of the watch interface, which we're going to address very shortly. And of course, the P2P gossip sync could be argued as the default implementation of the gossip-based network syncing.
One thing I think we forgot to put on that slide was that there's something called Lightning Block Sync, which is sort of a default sort of implementation for querying a full node for blocks and sending those blocks through that block connected method, and also handling reorgs too, block disconnected, all of that, into the channel manager, into the chain monitor for processing essentially. Those are sort of listeners in our world. And again, so background processor sort of orchestrates a lot of this, not with the blocks, but as far as like the peer manager, for instance, and actually querying events and sending them to your event handler as well.
Here's some hackathon inspiration for you.
Yeah, so Watchtowers, I mean, we actually had a Spiral grantee, Sergey Legato, he's working on a Rust-based Watchtower implementation using LDK. That might be something of interest if you want to try to hack a bit. Multi-home backup, so when you're backing up your state, like if you're just doing it on your device, that could, if you lose the disk for whatever reason, you may want to have cloud backup. You can always have various I guess strategies for doing backups and persisting your data. What else we have? Oh, probing. I guess Tony has done some probing in the past. Some, a little bit. Yeah, so Tony used LDK for doing probing of unannounced channels, and I think you saw there's like 10 Bitcoin worth of unannounced channels at least minimum.
Found so far.
Yeah, found so far. But probing is a strategy basically to determine what, or more generally, I guess, is or typically maybe used for finding out what the liquidity balance of a channel is to determine if you could actually successfully send a payment through. So I think we, in the LDK world, would love to have like an actual prober that you could use, although there's some, I guess, like privacy implication of always probing the network. There's a lot of debate around that. But the ways to make payments more reliable, and probing is one of those ideas. I think our last thing, then custom channel scoring. Again, I mentioned before that we have the score interface that you can implement on your own. And so basically what it is given a channel and an amount and a direction, I guess, that you're trying to send a payment, you give back it's a penalty and MSATs that you would be willing to pay to avoid that channel, basically. And then with that in the fee, that I guess constitutes the cost function of the sort of.
So there's a lot of potential hackathon approaches that you can take. This is all just inspiration, and just feel free to come up with any of your own ideas. We also wanted to go in the weeds a little bit and describe some of the methods that you will need to implement. There are methods that you'll need to implement on the peer manager, which are automatically implemented by the background processor. However, as it turns out, we need to go through another 7 slides over 30 seconds. So I'm just going to skip past all of these.
They're in the documentation.
And I want to conclude with saying, first of all, thanks for listening. And I hope that you are inspired to help us improve LDK. It is a really major project, and the flexibility does not come for free. It really takes a lot of sweat. And we are also very excited to say that we're funding grants, including designer grants. So definitely, if you feel like it, we would love to see you apply for one.
All right, thank you. Any questions?